All right, y'all, here we go. So now we're going to talk about history and etiology of stuttering. So the idea here is that we're going to talk about some of the wackadoo and not so wackadoo things that over time we thought caused stuttering and caused people to stutter. So when someone says, well, why do people stutter? Now you'll have some different ideas that perhaps you can share with them. All right, so here we go. Maybe. Yep. All right, so back in the day, with the Freudian or Neo-Freudian, so any of you that have had to take psychology know who Freud is, and we know that he was really super obsessed with pieces and parts. So he felt like stuttering was a repressed need, as in kind of like constipation. Your words were words, you were like doo-doo you could not get out. So we've moved on from that. There's no empirical evidence that supports the idea that stuttering is actually a repressed need. Some of his buddies went on to kind of help with that idea, but it didn't really take root. So there is no research that has ever showed that people who stutter are more psychologically more likely to have any kind of psychosocial adjustment issue than anybody else on the planet. Being a person who stutters does not mean you are crazy. Or that's a terrible word. It doesn't mean that you are struggling with any other mental illness that anyone else might not be struggling with too. So one of the things that is really important to discuss with parents is the fact that if their child is stuttering, it doesn't mean that they are suffering from some terrible mental illness. Stuttering is stuttering, and it is not an indication that their child is really going to struggle with mental illness. Okay. So then came along a really great idea that if you call it stuttering, then it will be stuttering. So kind of a self-fulfilling prophecy sort of idea, where people would say, oh, you're stuttering, and then bam, you're a person who stutters. So the all of us have, I just did it, hesitations or pauses or places where we're trying to think of what we want to say. And the idea is that if you have a child who is doing that and you say, stop stuttering, then all of a sudden they are going to be a person who stutters. That it, like I said, is kind of a self-fulfilling prophecy. So there was no evidence that supports that either. Using the word stuttering to describe stuttering does not make someone more likely to persist as a person who stutters um, or to become a person who stutters. So there was a not so ethical study that was done, I think in the 60s. It's called the Monster Study now, where the researchers were in an orphanage, and there were, I think, 6 kids who stuttered. So they took 6 kids who didn't stutter and told them that they did, that their speech, there was something wrong with their speech, that they were stuttering, and that they were really having problems, blah, blah, blah. And it turns out that they did not start to stutter. Now, unfortunately, they did cause psychological harm by making these children very hyper aware of their speech and very worried about their speech. And it really kind of destroyed the self-efficacy about talking for a few of the kids. So years and years later, this was actually litigated, and the families of the children who participated were actually compensated. All right, so there are more behavioral theories. So these go on the kind of stimulus response sort of idea. So the idea is that, let's say you come home from work and Precious Peanut is standing there, and you're so excited to see Precious Peanut, so you snatch them up off the floor and you smooch their little face, and then you toss them up in the air right as they go. So they have this great, this quick intake of breath where their vocal folds get really tight, and then they essentially block. And that turns into stuttering somewhere down the line. So, yeah, let's see what the research says about that. So they're really inconsistent results, and especially in the daily environment, that lead us to believe that there is a conditioning to stuttering. Um, and it really, and one of the places that this particular theory really falls apart is when you look at the reasons why there are increases or decreases in a child's fluency in any part of a given day. And anyway, because think about it this way. All right, so you remember classical conditioning and Pavlov and his dogs, right? So he rang a bell every time he fed the dogs, and then it got to, the dogs started to associate the bell ringing and food so much that if he just rang the bell, they started to salivate in anticipation of being fed. All right, so the idea here is that if that's the case, if you are conditioned to stutter, then you are going to stutter all the time. And we know that that's not really the way stuttering works for a lot of people. For some people who are very severe, that is true. They do stutter all the time. But for most folks, that isn't the case. They actually have times where they're fluent and times when they're not. So let me get my little laser pointer. Boom. So there you go. So that's not really a great explanation. So one of the things, there is a treatment called the Lidcombe program that is based on a contingent response to the moment of stuttering, and it's actually very, very effective. We're not entirely sure what about it is effective. So the idea is this idea that contingent responses. So what happens is the as I understand it, is that the child will say something like mom, 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 I will want the ball, and the mom will say something like, "Oh, Precious, your speech was a little bit bumpy right there." And then if they were school age, then the parent might say, "Can you say that for me again?" If they were preschool, they would just kind of let it slide there, like, "Oh, that was some bumpy speech." And that's a contingent response. The idea is that it kind of highlights that moment of stuttering or distracts the child from the moment of stuttering, like, what? Okay, so the way I think about it is if I came up to you and said, hey, that house is on fire, that house is on fire, and you were like, whoa, that's some bumpy speech, I'd be like, what? And that would distract me from the fact that stuttering occurred. So anyway, I'll leave you to your thoughts on that. So one of the other things we know, there's been some really great research on neuroanatomy and physiology of people who stutter, generally adults, but the technology is getting better, and we're getting some really interesting research on children who stutter as well as adults who stutter. Okay, so one of the things that Orton and Travis in the 20s and 30s found is that there were so one of the things that most of us have is what's called cerebral asymmetry. And what that means is that one side of our brain tends to be a little bit bigger and shaped differently than the other side of our brain. So symmetry means that things look exactly alike on both sides, and asymmetry means that one or the other side looks different from its other side. that was really articulate. But things that they found is, or they started exploring, was left-handed dominance and folks who stutter. There's a test called I think it's WADA test, where it's one of the tests they use during neurosurgery to try to keep speech areas intact. So what they found, though, is that there were certain parts of the brain that they could stimulate during this test that made it more likely that the person would stutter. There are also dichotic listening tasks. So that's when, let's say you have on earbuds and words are coming in through one earbud and music is coming in through the other earbud. So what the researchers might do is ask you to repeat the words that you're hearing. And then what they found is that folks who stutter tend to have more difficulty when there is competing information coming into their ears. All right, so EEG studies, so those are electroencephalograms, and ERPs, which is evoked response potential. And an evoked response potential, or an ERP, is taken from the data of an EEG. So what an ERP is it is looking at, so think of the spaghetti hats, that is what they called them. My oldest daughter participated in several of these when I worked at Vanderbilt, because that's what you do when you have a kid and you're a researcher, is you get them involved in other people's research. So anyway, so what they found was that there's a suppression of neural activity in the cortex, and that the right hemisphere for people who stutter reacts differently than it does in people who do not stutter. So using neuroimaging of cortical and subcortical areas like CT, MRI, MRA, which is magnetic resonance arthrogram, and functional things, including functional MRI, that we found, or researchers found, that there are differences in people who stutter when you compare their brains to people who don't. So the left asymmetry, so in folks who don't stutter, the left hemisphere tends to be bigger than the right hemisphere. Part of that is, we believe, because speech and language planning and processing primarily takes place, say that quick, in the left hemisphere. All right. I'm going to pause for just a second because my dogs are barking. All right. So the left asymmetry that we're talking about is, like I said, in people who don't stutter, their left hemisphere seems to be bigger. And NFS stands for normally fluent subjects. Sorry, there you go. So what they found is that both the right and left planum temporal is larger in people who stutter. And the left asymmetry, so in people who stutter, what they found was their left hemisphere didn't tend to be bigger than their right hemisphere. All right, so this particular bullet means that the greater volume of white matter in the left hemisphere for the normally fluent subjects in the people who stutter, though, have more white matter in the right hemisphere. So normally fluent subjects, more greater white matter in left hemisphere. People who stutter, more white matter in the right hemisphere. And the idea is that white matter is what transmits information throughout your brain. And it was also found that there's more activity in the right frontal operculum and in an area called BA45. All right. One of the really interesting things is that there have been several studies that have shown that with treatment, people who stutter can actually kind of reverse the left hemisphere, right hemisphere findings, and people who stutter that are in therapy or doing speech treatment, stuttering speech treatment, actually will have more activation in their left hemisphere over time. All right, so um, that's what we're talking about here, is that there tends to be a loss or reversal, maybe even a reduction of the asymmetry between cerebral areas when we compare people who stutter to normally fluent subjects. Now, for this, we're talking about adults. This is really the findings from studies with adults. All right, so aberrant means unusual. So aberrant features of white matter, connectivity, and track size. So that's what I just told you about there being differences in white matter, which again we think is what transmits signals and information around your brain and storage, etc. That there are differences between people who stutter and normally fluent subjects. We also have found that there are abnormal patterns in the parasylvian cortical folding, as in one side of your brain, and this is aberrant sulcal patterns and increased gyrification. Okay, so what that means is the folds and wrinkles of the brains of people who stutter are different looking than the folds and wrinkles in the brains of people who don't stutter. All right, so now we're going to talk about some functional difference between people who stutter and normally fluent subjects. So in comparison to fluent speakers, people who stutter show an overactivation in the cerebellar vermins and the frontal eye fields, which tells us that there's something going on with visual processing, and your cerebellum is about coordination of fine motor or of motor activity and sensory information in general. So what it tells us is that people who stutter are accessing this sensory information and their visual fields perhaps differently than people who don't stutter. Okay, so the anomalous right dominant lateralization, so blah, blah, blah. So it's right dominant in these areas in the cerebellar vermins and the frontal eye fields, which is different than normally fluent subjects. And that there are areas of motor, non-motor areas of activation that are not seen in the fluent speakers. So for example, in one study that I read, and I apologize, dear friend researcher, that I don't remember your name or the year it was published, but participants were asked to, they were in an fMRI and they were asked to read, silently read particular statements or passages. And what they found is that even in a non-talking, like so in silent reading activity, the activation of people who, the brains of people who stutter was very different than what activated in the brains of people who don't stutter. And that's this, there was additional motor and non-motor areas that activated for people who stutter versus people who don't. All right. And then this goes along with the dichotic listening tasks, is that there was an absence of auditory activations bilaterally. So that means that maybe folks who stutter are only processing auditory information, which speech is, differently than people who don't stutter. One of the other things that has been found is that there is a small level of what's called basal ganglia activation. So your basal ganglia is a deep brain structure. And I'm not showing you pictures of all of this because I want you to go and look them up, find them, get into Google Images and look up basal ganglia, look up basal ganglia activation, and see this for yourself. it's one of the best ways to really get into it. But I can tell you about it and I can point to it and I can say, this is this and this is that, but you're not going to get as much out of it, I promise you. So find a good Google image of a basal ganglia and look to see where the putamen is, and know that there is some basal ganglia activation in fluent speakers that's not observed in those who stutter. And we think that perhaps these small aberrations or differences in the basal ganglia are associated, well, we know that they're associated with neurodevelopmental disorders like stuttering and autism spectrum disorder and attention deficit hyperactivity disorder and Tourette's and all kinds of things. All of these different kind of very language-based disorders live kind of in the same area on the basal ganglia. So consider that for a bit. All right, so we're going to talk about some more hypotheses. So in the late 90s, some really wonderful Dutch gentlemen, Kolk and Postma, came up with the idea of what's called the covert repair hypothesis. So one of the things that you find when you talk with people who stutter is some people who stutter, when you talk to them, they sound very, very fluent, but when you ask them, you know, were you stuttering? They'll say, oh my gosh, heck yeah, I was stuttering, but it doesn't get from it doesn't actually come out overtly as what we could identify as stuttering with our ears, because that person is changing words and doing all kinds of things to make the word come out fluently. So the person feels very much like a person who stutters, even though I'm not hearing stuttering in their speech. So the covert repair hypothesis was developed to really think about that, like what is going on in folks who really feel like they're stuttering pretty severely, but you're not hearing it in their speech. So the idea is that there is an internal monitoring system that as you're speaking and as you're preparing to speak, it's picking the words, and or as you're choosing your words and you're putting together, remember, go back to the first set of slides where we were talking about getting from idea to actual speech. What happens is that you are monitoring that whole process as it's going on. So as words are coming out and before they're coming out, I have a monitor that says that's the right word, that's the right word, that's the right word, nope, that's the wrong word, go back and fix it. So remember, I also showed you like the assembly line of Krispy Kreme donuts. Think of it as the person who comes and, or the camera or whatever that detects when the donut hasn't flipped and somebody comes and flips it. Or it's the person at the end of the line that takes any of the smushed donuts or the ones that didn't get iced right, whatever, and chucks them out of the way. So that's the monitor. It's looking for disruptions or imperfections in the message that you're trying to convey. All right, so this is talking about errors in phonological encoding. So remember, phonological encoding is putting the syllables that are necessary to make up words together and so that they make up words. Okay, so, and grabbing the motor plan that goes with it so that you can actually make words out of those phonological representations. Okay, so this is getting complicated, but the idea is that, again, think of the donuts on the conveyor belt, and if you think of each donut as is a phonological component and the box is overt speech. If, you know, something gets dropped out of the box on the way, or all 12 aren't put into the box, it doesn't make up a word. Okay, maybe that's a bad example. Hopefully you're following along here. This is the part I hate about virtual teaching. I have no idea if you're getting this or not. I hope so. Okay, so the idea is, so now we're on bullet number 3, that people who stutter possess a slow rate of phonological encoding. So think of it as their conveyor belt just moves way slower than in people who don't stutter. But the demands of speech and language and the rest of it are still there. So even if it is moving slower, the person is still being expected to communicate at the pace that everyone else does, which results in rushing a process that's not finished. And to keep my Krispy Kreme donut analogy going, you end up with some raw donuts, you end up with some not glazed donuts, or in this case, or maybe too heavily glazed donuts. It takes longer for everything to get there, for the words to be chosen, for the phonological encoding that has to happen in order to make up a word. And so it is likely, as you're trying to push the process forward, that you can make mistakes. All right, so the idea again is that there is your monitoring system, you're trying to push forward, which means that you're going to misselect. So there was a research project that we did while I was at Vanderbilt, and it was a speech reaction time or a voice onset time study. So what we were looking for is how long it took between seeing the picture and being able to say the word that goes with the picture. So for example, the picture was dog, and they saw the picture, maybe they heard a beep, saw the picture dog. We measured how long it took for them to say dog, and we felt like that was a measure of processing time. How long did it take them to get to the word dog? So one day I was calibrating the equipment, because that's what you do when you do research. You got to make sure everything works right. And so I was running through the paradigm, which I had seen like hundreds of times at this point, and it said duh, and then the prime was duh, and then it showed a picture of dog, and because I was only half paying attention and I was in a hurry, I said duck, because that's what I selected first. So I didn't detect and repair the error. I selected duck and set it before my internal system had time to go, nope, that's not the right word. So hopefully that helps. There's been some empirical evidence that actually supports the idea of the covert repair hypothesis, and it's some pretty neat stuff. All right, so we're going to move on though. We're going to talk about the X-plan model. So this one's pretty easy to remember. The X stands for, oh my God, execution. Good grief. Executing the talk about slow processing. That is a perfect example of covert repair hypothesis right there. The word did not come to me. The word execute didn't come to me, and so I was kind of stuck. If I was a person who stuttered, I might have been stuck and gone, X stands X, the X is execute. But because I'm not, and I'm wired differently in my temperament and all the rest of it, I just kind of laughed it out and then remembered executes. Okay. So the X-plan model, though, does elaborate on covert repair hypothesis, but it adds in that there's a separate linguistic and a separate motor system, and that those two systems are not linked to internal or external monitoring. The idea is that the internal cognitive linguistic system is the plan, an X plan, and it's the syntactic, lexical, phonetic features in order. So it's the words. So syntax is how words go together in a sentence. So let's take the dog barks as our sentence. The syntax is the word, and serial order means the syntax for the utterance, the dog barks, the is first, dog is second, barks is third. All right, and then lexical, the dog barks, it would be article, noun, verb. And then phonetic features, it would be the, d, g, b, k, s. There you go, serial order. And the motor process, organism, or the X, executes the plan that in order for speech to occur. So the idea is that stuttering occurs when your linguistic system is having difficulty getting the sequence together. So again, it kind of goes back to our conveyor belt idea, where something goes wrong somewhere in the process of planning, and that can result in a disruption of the execution, which results in stuttering because it cannot be it can't be executed fluently. So the bottom line with this one is that people who stutter have difficulties with motor timing, especially as what you're saying becomes more complex. So that's increased linguistic complexity. So the idea is like in what I'm saying, which is pretty linguistically complex, it gets harder to be fluent, which is what you've seen as my delivery here has gotten kind of worse along the way. All right, so because now we're 30 minutes in. All right, so there is actually some support for this research and the idea of the execution and the planning part of motor and linguistic planning and processing from a few different studies and from some structural and functional neuro imaging studies. All right, so now we're going to talk about feedback models. So the idea here is think of a frayed charging cord. All right, so you know how your charging cord gets bent like right up close to the end, either by the part that goes to the USB part or the part that goes into your phone, and it's all kind of hanging on. So you tape it up a little bit, and it's, you know, it's doing a little bit better, but it's not great, and sometimes it charges and sometimes it doesn't. That's the idea here, is that our system, because our brains work on an electrical system, the idea is that sometimes the signal getting around in your brain in order to activate the fluent speech, everything that needs to happen for fluent speech, that the signal is just not good. So kind of the idea of when you're in the middle of nowhere and you have no bars on your phone, you can't really talk well when there are no bars on your phone. And that results in an interrupted or distorted feedback, which then results in stuttering. Okay, so again, in feedback models, so there are lots and lots of studies of what's called delayed auditory feedback. So pushing forward with our cell phone analogy, it's the idea of, if you've ever been out in a place where you barely have bars on your cell phone because you're not getting a very good signal from the satellite from the tower, and you actually are trying to talk to somebody and it kind of cuts out and you're getting maybe every third word or so. That's the distorted feedback model. This delayed auditory feedback is when you're actually getting like an echo, when you're talking on the phone and you are getting an echo of your voice back to you. That's delayed auditory feedback, and it can be faster or slower depending on, like, sometimes the echo is like right away, sometimes it's you're 3 words in and then it starts echoing back what you said. That's delayed auditory feedback. Altered auditory feedback, on the other hand, is something like when somebody puts uses a voice modulator, so it changes the pitch and other characteristics of their voice. That's altered auditory feedback. Really not any great theoretical implications here, but delayed auditory feedback actually works really well with people who stutter. The problem is that it's not a lasting solution. So I always think of delayed auditory feedback of the Spanx of fluency treatment. So, you know, you're going to go out and you want to look nice and you want everything to look all seamless and whatnot. So you put your Spanx on, you squash yourself into it, you look nice in your dress, you come home, you take the Spanx off, and you look like you usually do. Well, that's kind of how delayed auditory feedback works. You put it on, you're fluent for a bit, you take it off, you go back to stuttering. So there you have it. Oh, yay, dog's barking. All right, so this is actually the last slide. So this particular theory is one of my favorites. The demands and capacities model is that you only have a certain amount of cognitive space to go around, and when you run out of it, you run out of it, and if the demand exceeds your capacity, then in the case of speech and language, then you start to stutter. So demands can be environmental or internal, and this is where in the next set we're going to talk about emotions. This is where your emotions can really cause you issues. So that's an internal thing where you yourself are kind of wadding yourself up. So your capacities can be motoric. So your ability to, have you ever heard different kinds of freestyle rappers? They're the guys that can go like crazy super fast, and you're thinking, God, I could never do that. Well, you're probably right. That's a motoric capacity. They have a motoric capacity that most of the rest of us don't. And then linguistic, it's your ability to formulate sentences quickly. You know, there's some folks, like one of my children, when they're getting in trouble, or if they're under pressure, will have the worst time remembering the words they want to say. So that's a linguistic capacity. And then social emotional, you know, your ability to produce smooth movements when you're under communicative or emotional stress. Think of what happens to your voice when you're crying, and how hard it is to talk when you're crying or when you're very, very upset. And then there is cognitive capacity, and it's your ability to use your metalinguistic skills, like when I couldn't remember the word explan, the X means execute, things like that. So there are lots of different ways to think of capacity and demand. So your capacities, think about it as water in the bucket. If the demand is for you to have a bucket and a half and all you've got is your bucket, well, that's all you've got. You cannot make the demand on meet the demand of the environment or your internal expectations. And in this case, stuttering would occur. All right, that's what I've got for this batch of slides. Stay tuned.